In this video, we're going to build on what we already know about writing linear equations to study some of the problems that can be solved using those equations. So let's review. We have two main forms of a linear equation that we'll be working with. There are a few others, but these are the ones that we'll focus on. The first is slope-intercept form, and this is the one that looks like y equals mx plus b. So in this equation we have two variables. We have an x and a y, and then we have two other letters here which aren't variables, but they do represent two different things. M is the slope and b is the y-intercept, so hence the name slope-intercept form. It's the slope and the y-intercept. Now keep in mind that that b represents a point 0b, or a point where this line will cross the y-axis. The second form is standard form, which looks like ax plus by equals c. And again, we have two variables, x and y. We haven't talked about a specific meaning for a, b, and c, so at this point our understanding of these is just that they would be replaced with numbers in a certain example. So for example, we could have the equation 3x plus 5y equals -8. So a would be 3, b would be 5, and c would be -8. So those are fixed numbers for the problem. The x and y can vary, but a, b, and c will stay fixed. Okay, so when we're studying applications of these equations, or in other words, for our purposes, they're going to look like word problems, we need to figure out which of these types of equations we could write, and then we'll do that, and then we'll use the equation to solve some problems. All right, but have these in the back of your mind, be familiar with these, and just know that these are options as you head into a problem. All right, so let's look at an example. This is from your textbook on page 376 if you wanted to follow along with that example. The standard fare for a taxi in one city is $5.50 plus 30 cents per mile. Write a linear equation that describes the cost of a cab ride in terms of the length of the ride in miles. Then use your equation to answer the following questions. Okay, so we'll start with the equation first and then go on to the questions. Since we're writing linear equations, we're going to be looking at things that have, or situations that have two variables or two unknowns. So I would say that the first step in trying to write an equation is to try to figure out what the variables are, or what things should be represented by x and y. And here I'm going to use an arrow. X and y represent something rather than an equal sign. If I used an equal sign, that would sort of imply that that x and y had a numerical value rather than a physical meaning. Okay, so your clue is in this sentence, write a linear equation that describes, and then it tells you what the two things are that we are supposed to describe. And they are the cost of a cab ride and the length of the ride in miles. All right, so we have the two things are dollars, the cost, and the length of the ride in miles. All right, now which is x and which is y? Sometimes it doesn't matter, but in this case we have another instruction. We're supposed to describe the cost of the cab ride in terms of the length of the ride. So whenever you see that phrase in terms of, it's the first thing, right, the cost of the cab ride, that's the y, and it's the second thing, that's the x. Right? This is also sort of giving you a clue that we might want to head towards an equation that looks like y equals mx plus b. All right? So this would be an equation that describes y in terms of x, or in other words, as some sort of a function or something that's been done to x. So with that being said, let's let x be the length of the ride in miles, and then y be the cost of the ride in dollars. Alright, so once we have that, we need to actually start writing an equation. And Let's aim for y equals mx plus b because of that phrasing the y in terms of x. Okay? Now you have a couple options for how to get to that point. If you already see something in this problem that could be a slope or a y-intercept, maybe you would jump to writing that equation directly. I'd like to also give you an option for if you don't see this or don't already know how to write an equation. So let's start. This is a basic method you can use on any problem involving a linear equation. We're going to make a little chart off to the side and try to find some specific values for x and y. And we can do this without an equation, just thinking about the given information and making some calculations on our own. All right, so let's say x is 1. All right, well then think about what that means. X is miles, so this would be the situation in which the cab ride is 1 mile. Now y is the cost for that ride. So if I go back to the first sentence, I know that the taxi fare is $5.50 plus 30 cents per mile. So the cost associated with riding 1 mile would be $5.50, just that standard kind of a base fare, plus 30 cents because I only went 1 mile. Right, so that cost would be $5.80. What about if x were 2 miles? Right. Well, now the cost would be still that $5.50, but now I would have 30 cents for 2 miles, so that would be plus 60 cents. Right, so now the cost would be $6.10. And we can do one more. If we rode for 3 miles, then that would be 30 cents times 3, or 90 cents. So now the cost would be $6.40. Okay, so we have everything we need now. Every time you have a pair like this, a pair of x's and y's, those are points. So I know that whatever this linear equation is, it's describing some sort of a line, and these pairs of x's and y's would be points on that line. So I'm going to pull out just 2 of these, right? 1 580 and 2 610. And then what can I do with that? Well, we have an equation to find the slope given 2 points. So that's powerful. I can use those 2 points to find the slope of the line. All right, so let me remind you of that equation. And that one is m equals y2 minus y1 over x2 minus x1. And this is something that we talked about when we looked at graphing lines in section 7.1. So if you wanted to find that in your notes, go back to that. All right, so to calculate the slope, I need 2 points, and I need to subtract their y values, subtract the x values, and divide. All right, so filling in my specific numbers, I'm going to use these first 2 points. Then the slope would be 610 minus 580 divided by 2 minus 1. All right, and that's going to be 0.3 divided by 1, or 0.3. Right? Now that should look familiar. Right? That's the extra 30 cents. So the only difference between the cost for riding 1 mile and 2 miles is just that extra 30 cents. Okay, so now I know the slope. All right, so back in my equation, I'm going to erase m and fill that in. Now I know it's 0.3. Now the other thing I need to complete the equation is the y-intercept. So we can find this in 2 different ways. First of all, I mentioned earlier in this video that b is really the point 0b, right, or the y-intercept, or when x is 0. So if you know enough about this problem to think about what the cost would be if the ride were 0 miles, then that would tell us what the y-intercept is. All right, so going back to the original problem, or the first sentence, the standard fare is $5.50 plus 30 cents per mile. So if you get in that cab before you even drive any miles at all, there's still a base fare of $5.50. All right, so the y-intercept would be $5.50. Now let's say that doesn't make sense. So maybe you're thinking about it and you're thinking, well, if I don't ride any miles, how is there even a cost at all? So there is another way to get to the y-intercept. Let me show you what that is. We can use this equation that we've started, and if I want to solve for b, I would need to know what x and y are. You can't solve an equation until you're down to just one thing to solve for. Right? Now fortunately I have some x's and y's that I could work with. So let me pick out one of those. I'll just choose this first one. Right? I have an x and a y that go together. So in this equation, if I substitute 580 for y and 1 for x, that's going to let me solve for b. All right, so now I would have 580 equals 0.3 times 1 is 0.3 plus b, and then I would subtract 0.3 from both sides of the equation, and then that would give me 580 minus 0.3 would be 550, and then on the right the 0.3's cancel and I'm left with b. So that's a second way to determine that b is 550. Okay, so that's it. So we can finish the equation now. We'd have y equals 0.3x plus 550. All right. Now we can use that equation to answer the questions that follow. All right, so we need to know what is the cost of a 6-mile ride, and maybe I shouldn't have erased the meaning of x and y. Let me leave that. I think I want that. Okay. So, what is the cost of a 6-mile ride? Right. Now, generally, the questions that follow the one which asks you to write the equation, generally they'll either give you an x and ask you to solve for a y, or give you a y and ask you to solve for an x. Right. So if we need the cost for a 6-mile ride, they're asking us to find y when we know that x is 6. All right, so I know x is 6, that's the number of miles, and then I need to know y. All right, so I would use the equation and I would replace the x with 6 and I would solve to get y. Okay, so we would have y equals 0.3 times 6 is 1.8, and then plus 550, and y would equal $7.30. Okay, now there's no units on this, so I've got to go back to my meaning of y and what I was finding. Okay, y is a cost, so we would put the units in ourselves. Okay, so the cost would be $7.30. The second question asks, if we have $20 in our wallet, how far can we ride? All right, so now we have money, we have $20, so that's a cost. So now we know that y is 20, and we want to know how far we can ride. We want to know what x is in miles. Okay, so in the equation, replace the y with a 20 and solve for x. Okay, so I'm going to subtract 5.5, and that's going to give 14.5 equals 0.3x, and then divide both sides by 0.3. And using a calculator, that gives x equals, I've got 48.3 repeating. All right, so if the problem doesn't specify, go ahead and round. You could say, an exact answer would be 48 1/3 miles, but if you wanted to round and say about 48 miles, that would be fine too. All right, so with $20, you can ride 48 miles. Okay, So we will try this again with a second example, but I did want to just make one observation. Notice that when we wrote this equation, y equals mx plus b, I showed you a way to find slope and y-intercept without really knowing which part of the problem were those two things. Right? But notice that there is a connection back to the given numbers. This 550 was the y-intercept, and this 0.3 was the slope. All right? So we'll do more with that in a couple minutes, but keep that in mind as we go into the next problem. All right, for this one, the United States Census Bureau uses demographic information to set a poverty threshold that is used to determine how many Americans are living in poverty based on an annual income. For an individual on her own, the poverty threshold was $4,190 in 1980 and has increased at the rate of about $220 per year since then. Write a linear equation that describes the poverty threshold in dollars in terms of years after 1980. And then we'll use the equation to answer a few questions. Okay, so let's focus on the instructions first. We're supposed to write a linear equation to describe the poverty threshold in dollars in terms of years after 1980. All right, so step one would be identifying the variables. So it's a linear equation, so we will work with two variables. We'll call them x and y. And then again, we have this instruction, write an equation in terms of. Right, so that another way of saying that is that the first thing depends on the second thing, right? Or the poverty threshold in dollars depends on how many years after 1980 it is. Okay, so the first thing is the y. Right, so y is the poverty threshold in dollars. Poverty threshold in dollars. And x is years after 1980. So let's talk a little bit about that. So it's not actually saying that x is the year 1980, it's years after 1980, right? Or in other words, when x equals 0, we're referring to the year 1980. Okay, it's 0 years after 1980. When x is 1, that's the year 1981, right? Or, for example, in the year 2000, we would ask how many years after 1980 is that, and that's 20 years after 1980. So in that year, x would equal 20. Okay. Now let's try to find some specific x and y values. All right. So we're given one of these. I know that in 1980, the poverty threshold is $4,190. Right, so what would be the x in that year? Well, we just said that that would be 0, and then y is the poverty threshold, $4,190. Okay. Now, I don't have a second year and a second dollar amount, but I do know that the poverty level is, or the poverty threshold is increasing at about $220 per year. All right, so in the next year, we would just add $220 to $4,190. So 1981, it's going to be $4,410. And in 1982, you would add another $220, so it would be $4,630, and so forth. Okay, so again, because of the clue that we're writing an equation for y in terms of x, let's maybe head towards the form of the equation y equals mx plus b. Okay, so I need a slope and I need a y-intercept. Now here, this is pretty easy to see what the y-intercept is if you know how to write that point. Okay, 0 and 4,190. Okay, so any point that has the x as the 0, that is going to be the y-intercept. Okay, so I know b is 4,190. What I don't know is the slope. All right, so again, I can use two of these points and the definition of slope to figure that out. right? So slope is two y values subtracted. So I'm going to go with the first 2 points again. And I'm going to subtract the y values. All right, so 4410 minus 4190, and the x's would be 1 minus 0. All right, and think about how we got from one y value to the next. Okay, we added $220, so that difference is 220, and then 1 minus 0 is 1. So the slope is 220. All right, so back in the equation, I can replace m with 220. And there we have it. There's an equation. All right, so again, notice those numbers are familiar. If we look back at the problem, 220 was given. That's the rate that the poverty threshold is increasing. And then we had 4190 as well, the specific poverty threshold in what we would call the initial year, okay, the year when x is 0, or 1980. So now let's use the equation to answer the two questions. So estimate the poverty threshold in 2010. All right, so that's a year, okay? So I need to find the x that matches that. So in 2010, that would be 30 years after 1980. And then I'm supposed to find the poverty threshold in that year. Poverty threshold is y. All right, so we're given an x and asked to find a y. So we'd have y equals 220 times 30, since x is 30, plus 4190. Okay, so if you multiply 220 times 30 and then add 4190, that gives $10,790. That's the poverty threshold in 2010. And then secondly, we need to find the year when the poverty threshold will pass 15,000. So now we know a y value, a specific poverty threshold, and we need to find the year. Okay, so let's let y be 15,000 and solve for x. All right, so subtract 4,190 from both sides of the equation, and that gives 10,810. Oops. And then divide both sides of the equation by 220, and we have x is 49.1363636 repeating. All right, so let's go ahead and round. That would be closest to 49 if we're going for a whole number. And then we need the year associated with that. So that would be 49 years after 1980. So to find the year, you would do 1980 plus 49, and that gives the year 2029. All right, so in 2029, the poverty threshold is expected to pass 15,000. Okay, so let's talk about let's go back to the equation in each of these two examples we've done. All right, so in the previous example, we had 0.3 was the slope and 550 was the y-intercept. So, and then in the second one, 220 is the slope, 4190 is the y-intercept. Well, let's look at those slopes first. In the first example, 30 cents is the cost per mile, and in the second example, that's the 220 is the rate that the poverty threshold increases per year. Right? So we had cost per mile, and then we had the rate that the poverty threshold in dollars was increasing per year, and per means division. Right? So in each of these two examples, these are actually rates, right? And that's the meaning behind slope. Slope is always a rate. It's a rate of change between the two variables y and x. Right? So think about how we get slope. Right? We find the difference between y values, or we could describe that as a change in y, and then you divide that by subtracting x2 minus x1, or calculating a change between two different x values. All right, so this is a rate which describes the change in y compared to the change in x. Right, so the units for slope are always going to be something per something, right, or whatever the units for y are divided by the units for x. Now the y-intercept, on the other hand, okay, in the first example it's $5.50. That was a base fare for the taxi before you even drive any miles at all. And in the second example, it was the poverty threshold in dollars in the first year that we were talking about, in 1980, right, or when x was 0. So that y-intercept is the y value when x is 0. Right. Now in the context of these problems, we can sometimes say that this is an initial y value. Right, so we think of the problem sort of starting at x equals 0. Okay, and then we would say that that's the starting y value, or the initial y value. Sometimes it's also common to call this some sort of a base amount, like a base cost or a fixed cost. Right? And the units will just match whatever y is. So in both of these cases, we're talking about y in terms of dollars. Right? So in here we had like an initial cost for a cab ride and an initial poverty threshold in the first year. Okay, so keep those in mind. Slope is a rate. Its units would be the same as the units for y divided by the units for x. And the y-intercept will be whatever the units for y. Alright, so let's look at two examples of an application where the equation is already given. Let's see if we can find the slope and the y-intercept and then explain what they mean in the context of the problem. So when you see these instructions in the context of the problem, we mean what do the slope and y-intercept have to do with the x and the y? So when you're describing these things, you're going to use the units of whatever x is and whatever y is. Okay, so in this first example, Kim purchases a bonsai tree from a local greenhouse. Its height h in inches after t years can be modeled by the equation h equals 1.5t plus 10. Okay, so in this equation we've used different variables h and t instead of y and x, but you can kind of see that this equation looks like slope-intercept form. Right, so if I were to replace h with y and replace t with x, then this would look like y equals mx plus b. Right, so to find the slope and the y-intercept, you don't have to make any calculations, you just have to pick out what they are based on the numbers in the equation. Okay, so matching up where m is supposed to be, it's the number in front of x. Right, I know that m is 1.5. Alright, so the slope is 1.5. And then the y-intercept is b. So b in this equation is 10. Right. Now I need to interpret them in the context of the problem. So I need to know units here for x and y. Right? Well, x in this equation is being replaced by a t, and I know that t represents years. So the units for x are years. And then the y has been replaced by an h, which represents height in inches. Right, so this is the height of a bonsai tree in inches. All right, so the slope would be a rate that describes or compares the units for y compared to the units for x. So this 1.5 would be 1.5 inches per year. Okay, well, what does that mean in the problem? All right, I have this equation is describing the height of a tree after t years. Okay, so this is the rate at which the tree is growing in inches per year. So if I wanted to write a sentence to explain this, I could just say that the tree grows 1.5 inches per year. Okay? Or you could say that the rate of growth for the tree is 1.5 inches per year, or something like that. All right, how about B? Well, the units would match whatever y's units are, right? And remember that this is really the point 0, 10. Right, so this would be the y value when x is 0, right? And x is years, so after 0 years, the tree would be 10 inches tall. Right? So she purchased this from a greenhouse. So what would 0 years mean? You could say that this is the height of the tree right when she purchases it. So it's like the initial height or the base height, the starting height when she purchases it. So the tree is 10 inches at time of purchase. Okay, so there's some flexibility in how you describe this, but the things that you would need to do would be to definitely use the units years and inches, and then just talk about the slope and the y-intercept in actual real words. So describe this in terms of the tree, the greenhouse, years, inches. So, make some physical connections to the problem. Don't just leave it at, well, m equals 1.5. We want to know what that means. Okay, let's look at one more example. Total U.S. military expenditures from 2000 to 2008 can be modeled very accurately. That should be a by the equation. Y equals 33.285x plus 220.458, where x is years after 2000 and y is expenditures in billions of dollars. So first, find the slope and the y-intercept. Okay, so this equation is definitely in slope-intercept form. So I can pick out the m as the number in front of x. Oops. 33.285. And b is 220.458. Okay, interpret them in the context of the problem. What do they mean? Right, so the units for x would be years, and then the units for y would be billions of dollars. So we're talking about how much the U.S. military spends in billions of dollars in any given year after 2000. All right, so looking at the slope, its units, this is a rate, and it's going to compare y to x, so it's going to compare the billions of dollars, so billions of dollars, to years, or billions of dollars per year. All right? Or in other words, this is the rate at which the military expenditures are increasing. So this means that every year they spend an additional $33.285 billion. All right, or you could say every year the expenditures are increasing by $33.285 billion. All right. So increasing or decreasing, those are words that you can use to describe rates. Okay, like if you had a car's rate in miles per hour, you know if the rate was 60 miles per hour, then that means that every hour that passes, the car's distance increases by $60. Or I'm sorry, 60 miles. Okay, how about B? Well, B is the point 0 to 20.458. All right, or when x is 0, y is 220.458. Okay, well, what does x equal 0? What does that mean? X is years after 2000, so when x is 0, that's the year 2000. And then y is the expenditures in billions of dollars. So this would just mean that in the year 2000, expenditures were that amount. Expenditures were $220.458 billion. And we talked before about an initial value. So here, the initial year, this equation only describes the expenditures from 2000 to 2008, and then it's not an accurate description of expenditures for other years. All right, so the initial year that the equation is valid for is 2000, and then this is the initial cost in that year. Okay, so in this video we've talked about two things, two main overall ideas: writing an equation based on a word problem, and we've written ones in slope-intercept form, y equals mx plus b, and then we've sort of gone backwards and we've looked at equations and tried to describe what the slope and the y-intercept mean in the context of that problem. In the next video, we're going to look at some other examples of applications where perhaps it's easier to write the equation in standard form rather than in slope-intercept form. Thanks for watching.